Anyway. Alright, how y'all doing? I'm your man, John Wilson. Today we're going to be working on Module 5.1, the B side of it, the stuff we didn't get to last time. And specifically today, we will understand how to write an equation in slope-intercept form to model a linear relationship given a situation, using the slope and y-intercept for coordinate pairs. And then we will apply this to real-world problems and situations. So now, we're moving away from graphs and tables, and we're moving into real-world situations, which means your favorite word problems, because we know that real-world situations are word problems. Now the thing is, I probably rewrote this lesson 3 or 4 times to try to make sure it is as straightforward and as slowly scaffolded up as possible. Scaffold means we build on one little concept to the next one, to the next one, to the next one, to make sure you understand exactly what it is we're doing here. But we have to begin with the basics. We have to make sure that by now, hopefully, you know that when we write a linear equation, we still must identify the same 2 things. We have to find the what? Slope, that's our M. And then we have to find our initial value, the V, which is known as y-intercept. Okay, so we got to find those 2 things. You got to find the slope, got to find the y-intercept, then you can write your equation. A couple different ways to do this. I'm going to walk you gently through the meadow so you understand what it is we're talking about. Now, when I do word problems, I got this idea from a friend. If we're talking about a real-world situation that involves a person, I leave the name blank. And your job is just to write your name in there, because it makes it a little more personal. So I'm going to write my name. I'm going to say that John goes to the bowling alley and pays $5 to rent a pair of bowling shoes, plus $8 for each game he bowls. Now, looking at this situation, we need to identify the slope and the y-intercept. The question is, how do we do that? Well, let's start by figuring out what the y-intercept is. The y-intercept can take on a wide range of possibilities in a real-world situation. Generally, it's going to refer to an upfront fee, or the thing that you pay only once, such as in this situation. Which one of these items are we only paying for once? What do you think? Rudy? The shoes. We're just paying one time for the shoes. You've been bowling. When you go up, do you pay for shoes each time you bowl a game? No, you pay for the shoes once. Hopefully you bring your own shoes, because those shoes, smell a little bit. It's also known as the starting point, such as when we did that problem for homework about the balance of a bank account. When the bank account started, at what month were you at?
0.
0. That was your initial value, your initial deposit to the bank. It's going to basically boil down to the item in this situation that is not changing. The price of shoes here is not changing. It is constant. It is always going to be $5 for you to rent those shoes in this situation. However, there is something in this situation that is going to change, and that is going to be the slope. Now, why does the slope change? Well, the slope, what's another name for slope? 4 words. Ugly shoes. What is it?
Constant rate of change.
Constant rate of change. It's changing. So the slope is the item that is changing in a situation. It's usually described using keywords. Here's a couple of them. I don't like to give out big lists of keywords. I like you to relate the problem to the real world, and you personally identify what the slope is. I can give you a million keywords, doesn't mean you're going to memorize them. However, if you can identify with the problem, you can more easily understand it. But here's a couple of the keywords that indicate change. Per, like 50 miles per hour, we're traveling at a certain rate of speed. Each, you deposit $50 each month, a monthly bill, a daily wage, a yearly salary. All of those things are changing and growing over time. So if I worked for 1 year and I made $50,000, in 2 years it'd be $100,000, 3 years $150,000. It's changing. So to identify the slope, we want to find out what is going to change. Looking here at the situation, if I were to bowl one game, ignore the shoes for right now. Let's just talk about the bowling, just the games. If I were to bowl one game, how much would it cost me? $8. Once again, ignore the shoes for right now. If I were to bowl 2 games, how much would it cost me? $16. And 3 games? 24. So this is going to change depending on the number of games that I bowl. Is the cost of shoes ever going to change? No. That's constant. That's your y-intercept. This is your slope. So once again, looking at this situation, let's see if we remember what I just told you. The Fiamma. What's the y-intercept here? What number? 5. Yeah, it's the cost of the shoes. It's not changing. It is 5. And then, Corey, what, pray tell, is my slope here? 8. Why is 8 my slope? Because it's changing as we go. We play 1 game, $8. 2 games, $16. So on and so forth. So my slope is 8. And then using that information, I can then write an equation. Shimon, what is my equation going to be?
Y equals 8x plus 5.
B-E-A, beautiful. Y equals 8x plus 5. That is my equation. This is not a hard concept. You just have to really remember, when identifying the y-intercept, it's what's not changing. When identifying the slope, it is what's changing. All right? Let's go through a couple real quick here. Once again, we're going to write your name. John is making bead necklaces. Apparently, that's what I do in my free time. I go home, I make a whole bunch of bead necklaces, and I sell them at the swap shop. Looking at this situation, it says a necklace contains 20 spacers plus 4 beads per inch of necklace length. Who thinks they have an idea what the slope is here? Connor James. What the slope is. And what's the key word? Okay, 4. Why 4? You see a key word around 4?
Per.
Per. That means that every inch of necklace, it's going to be 4 for 1 inch, 8 for 2 inch, 12 for 13 inch. That's changing. So my slope is 4. What's the y-intercept there, Connor?
20.
20. The necklace contains 20 spacers. It does not say anything about 20 changing. Every necklace contains 20 spacers. This is changing. This is not. That is my y-intercept. And then Connor, finish it up. What's my equation?
Y equals 4x plus 20.
Good. Y equals 4x plus 20. Good job. Hold on him. 1. Nieto. A hummingbird beats its wings at 150 BPM. Do you have an idea what BPM stands for? Beats per minute. Now, 1, looking here. What's my slope?
I think it's
What's changing here? Let me ask you a question. In 1 minute, how many times are those wings going to beat?
in a minute.
Yeah.
150.
Okay, and then in 2 minutes.
300.
So is this changing?
Yes.
Yes. So is that going to be my slope? Yeah, that's changing. Now the next question is, what's your y-intercept going to be here? Think about it in a real world context. If a hummingbird is sitting on a branch, not flying anywhere, are its wings beating, yes or no?
No.
No. So my y-intercept in that case would be what?
0.
0. My y-intercept is 0, which means I can write this equation as what?
Y equals 150x.
Perfect. Y equals 150x. Hopefully the hummingbird is sitting on a branch when it's not beating its wings, because if it's not, that means that hummingbird is going to hit the ground rather quickly. Question? Okay, well think about it. Looking at that situation right there with the hummingbird, 150 beats per minute, right? So, in this equation, let's say this is our equation. This is the equation. After 1 minute, if we substitute in 1 for x, that means the hummingbird beat its wings 150 times. This is going to change because if I were to substitute in 2 minutes, how many times did it beat? 300. And the reason the y-intercept is 0 is because this is a real world situation. Imagine the hummingbird. While it's flying, it's beating its wings. You with me? So this is going to change. After 2 minutes, 300. 3 minutes, 450. 4 minutes, 600. 10 minutes, 1500 beats. That's changing. The reason the y-intercept is 0 is because if the hummingbird is not flying, if it's just sitting on the branch, is it beating its wings? No. So before the hummingbird takes flight, at minute 0, when the hummingbird is sitting on the branch, before it flies into the air, it's not beating its wings, right? So the y-intercept is 0. If you want to look at this as a graph, you can look at it like this. This is time in minutes, and this is the beats of the wings. So, when the hummingbird is sitting on the branch, right here, before it takes flight, no time has passed, the wings have not beat, have they? Now the hummingbird launches into the air. I'm not a hummingbird, that's why I fell to the ground rather quickly. And after 1 minute, it has beat its wings 150 times. After 2 minutes, its wings 300 times. That's why this is my slope, because it's technically, this is my y, this is my x, it's 150 over 1, y over x. If we do 302, we actually plug this into the slope formula. 300 minus 150, 2 minus 1 gives me 150 over 1, so my m is 150. If I were then to go further and plug this into my slope formula, let's say I use this coordinate pair. So my m's 150, my x is 2, this is 300, plus b, right? Remember how to do this? What's 150 times 2? 300. 300 plus b. 300 is equal to 300 plus b. So to find the y-intercept, I subtract 300 from both sides.
0.
What's 300 minus 300? 0. So my y-intercept would be 0. Make sense? All right. We got one more to do, and then I'll let you go to lunch. Yes, they eat lunch. Yes, I let them eat. All right, last one. Maybe you get the horror movie reference here. Blank will say John goes to Crystal Lake Campground and pays $32 for each night plus a one-time trash disposal fee of $11. Christopher, what's the slope?
32.
32. Why? What's the key word? Each. That's changing. Each night. That's going to change. One night 32. 2 nights 64. So that's 32. But when you walk in the door, before you can camp in for even a single night, they collect something. It's the upfront fee of how much? $11. And then Francesca, what is my equation?
Y equals 32x plus 11.
Beautiful. Y equals 32x plus 11. Any questions on this? No? All right. Good. Now that we know how to write the equations, let's try to go in and see what happens when we actually have to evaluate them out for a given time or a given value, depending on what the situation is. It starts off the same. We got a situation. We have to write an equation from this situation. So if we look here, the cost of renting a sailboat is $22.50 per hour. So let's say that Pukas wants to go and rent a sailboat. It's $22.50 per hour, plus he's got to pay $9 for a life jacket for himself so he doesn't drown. Okay, we want to write an equation and slope-intercept for that, but then we want to go one step further. Real world connection. We want to figure out how much Pukas is going to have to pay if he sails for 4 hours. So we start by identifying the m, the b, we write the equation, and then we have to figure out exactly where this 4 is going to go. Let's start by identifying the m. Let's go to Dylan. What's my slope here?
The slope would be 2250.
Okay, what's the key word around slope that lets you know that's what's changing?
Per.
Per hour. 2250 per hour. That indicates change. 2250 per hour. It's changing on the hour. So that is my slope. Since it is dollars and cents, write it out. $22.50. We're talking about dollars and cents. Usually we wouldn't write the 0 in a decimal like this. Dollars and cents. Let's make sense. All right. Cha. C-Cha. Sebastian Cha. What is my y-intercept then?
9.
9. And then what's your equation for this going to be?
Y equals 22.5x.
22.5, 0x.
Oh,
Right? We're talking about dollars and cents. Okay.
0x plus 9.
Y equals 22.50x plus 9. Good. So we have our equation. Now, let's rewrite our equation there. It's jumping. It's just a lad. Love you. It's just jumping out the hand. It's a hot pan. Y equals 22.50x plus 9. We want to find out exactly how much it's going to cost us to rent the boat for 9 hours. Now, we need to identify
4 hours.
4 hours, sorry. We need to identify where this 4 is going to be substituted into our equation. We have a y, and we have an x. So you have to think about it logical. 4 represents what? 4 what? What are we talking about? 4 what?
Hours.
4 hours. What represents hours in this situation? The x or the y?
The X.
The x, y. Why the x? The x is the what? Is the x the input or the output? X is the input. You put in 4 hours, you're going to get out a total cost. So these 4 hours right here, this is what I'm putting into the situation. I would then get out my total cost for 4 hours. So I'm going to substitute in 4 for the x. Y is equal to 22.50 we take the x, we remove it. What's happening between the 22.50 and the x, guys? Multiplication. So parentheses times 4 plus 9. That's my input variable. So that goes there. Then we just do our simple multiplication. What is 22.5 times 4? 90. Don't forget to add the 9. That's a common mistake. People do the 90, they do multiplication, and assume that's their answer. Not your answer. You must add the 9. So the total cost that Pukas would pay for 4 hours would be $99. Let's try another situation here. Remember, real world situation, think clearly. Try not to work ahead here because we don't want you to get lost in the shuffle. Rihanna, can you read this for me?
The balloon is currently at an altitude of 16,000 feet when it pops. The balloon begins to fall at a rate of 32 feet per second. Write an equation to model this situation.
Okay, so we got a balloon. Balloon is up in the air. And then poof, it pops. And then it begins to fall at a rate of 32 feet per second. So my first question to you is, Brianna, what's the y-intercept here? Where did this start? Where was the balloon when this whole problem started? Where did we begin? 16,000 feet in the air. The balloon was 16,000 feet in the air when this problem started. Specifically, the balloon is currently at an altitude of 16,000 feet. That's where we start. That's our initial value. 16,000 feet. That starting point's not going to change. We're not going to go back and say, well, now it's at 17,000 feet. No, it always started at 16,000 feet. That starting point did not change. So that's my y-intercept. There's a reason I did that first, because I want you guys to think about the slope here carefully. Viviana, don't disappoint me. Viviana, what's the slope?
32.
Wrong. It's not 32. How many of you think? How many of you thought the slope was 32? How many of you think it's something else? Maria, you didn't raise your hand either time. Okay, let's show you what happens again. You missed it. This is the balloon, right? Some of you are starting to come now. This is the balloon. Balloon pops. Watch the balloon. What happens when it pops?
Oh, negative.
Oh, negative.
So is your slope positive 32 or
Negative.
32? Now you were right in the fact that it was 32, but there's a big difference between positive 32 and negative 32. Specifically, the balloon falls at a rate of 32 feet per second. So you have to be careful. You know it? Why'd you say it?
I tried to and you didn't call me.
I didn't see you say it. So it falls at a rate of 32 feet per second. You have to be careful. You have to read the whole problem. Don't just look at the numbers. Make sure you see if there's any keywords that indicate something might be negative. You could have a negative y-intercept as well. Let's say we were talking about a submarine that was 10,000 feet below sea level. What would the y-intercept be there? Negative 10,000 when the problem started. And then let's say it went up at a rate of 50 feet per second. That would be y equals 50x minus 10,000. You could have a positive or negative y-intercept, a positive or negative slope. Lucas, you had a question.
Yeah, I just realized it was a negative. I realized it was a negative before because I seen the graph that was going down.
Plus this big graph is sitting right here in front of you guys. You notice that as we go from left to right, the graph is going down, which indicates that the slope is negative. Or the word falls. I mean, I have to give you something to let you know that it's going down. So we have our slope negative 32. We have our y-intercept at 16,000. Viviana, what is the equation here?
Y equals negative 32 plus 16,000.
Okay. What are you missing?
Y equals,
Okay, I'm going to say exactly what you wrote. Y equals negative 32 plus...
Okay, x.
Don't forget the x. Without the x, it's nothing. It's nothing. Then you just got y equals, technically, if you didn't have the x there, you would end up with y equals 15,968.
Did you get 15?
Because if she takes away the x, it's just minus 32 plus 16,000. That's up here, the brains. If that's wrong, we'll go back on the video to play it back. Oh, it's wrong. He did that math wrong in his head. No, but I'm right. Okay. Follow-up question. We want to identify how long it will take the balloon to reach the ground. So think about it. Once again, we have a balloon. Balloon's traveling through the air. Balloon pops. Here it was 16,000 feet. When it hits the ground, what altitude is it at?
Zero.
Zero, because it's now smashed into the ground. So to do this, you need to think about what the input is and what the output is here. Looking at, well, let's say we took the graph away. Let's just say we took this away. for a second. Looking at this problem, what's my input? What's my output?
I have a question.
You have a question? Okay, question.
Couldn't you just call it couldn't you just like divide 16,000 by 32 to see how long?
But it's not 32, is it? It's negative 32. And nobody pointed out that I forgot to write there again?
You wrote it, but then it disappeared.
Disappeared.
Yeah.
Magic. All right. So, but that's not a 32. It's a negative 32. So if you divide it by a negative 32, now you're saying that when the balloon hits the ground, it would be at negative 500 seconds. So somehow you have created a time machine. You've gone back in time. Before the balloon ever launched, you dug a hole 500 feet in the ground, and you put it down there. Or, we can try to figure out how to solve this correctly. Input and output, right? So looking at this situation, Sydney, what's the input, what's the output here? What do you think?
Like out of 32 and
Well, just in general, in this situation, we have two quantities. We have the time in seconds, and we have the altitude of the balloon. So what's the input, what's the output?
output is 1600.
Well, of those quantities, altitude or the time in seconds? Which one of those is the input, which one's the output?
Time seconds is the output.
So you're saying that time will not pass unless the balloon's falling. So let's think about this again. Balloon's going through the air. Balloon pops, balloon falls. The altitude is the output because as time passes, the altitude is getting what? Lower, 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 lower. So bringing this back now, of course it's not going to be there. Bringing this back now so you can clearly see it. My input is the time in seconds. My output is the altitude. As time passes, the balloon is slowly approaching the ground. So that's my y, that's my x. Now, the reason I tell you that is because we have to figure out where, and it disappeared again, right?
Yep.
We have to figure out where to put 0 into this equation. We have y equals negative 32x plus 16,000. Since y is the output, since altitude is the output, and we care about the balloon when the altitude is 0, am I plugging in 0 for y or for x? What do you think? X is the input. That's time. I'm trying to find how long it will take the balloon. I'm trying to find x. I'm trying to find time, how long it will take. So I need to plug in 0 for y, because y represents my what?
Altitude.
My altitude. And I would plug it in like this. 0 is equal to negative 32x plus 16,000. And then you just solve the equation. I'm going to wait for all of you to look up here because I want to make sure that I just have to do this once. It's a two-step equation. We're going to solve it together. When we solve equations, I want you guys to understand that this equation has three terms. It has two constants, 0 and positive 16,000, and there's one variable term, negative 32x. When we solve an equation, the goal is to get what all alone by itself? X, or the variable. In this case, the variable is x, so we want to get x all alone by itself. So I need to get rid of the 16,000, I need to get rid of the negative 32. We always get rid of the constants first, and then we deal with this negative 32, which is known as the coefficient. Lots of vocab for you coming at once. Basically, it just boils down to inverse operations. This is a plus 16,000. I must get rid of it from this side of the equation. What's the opposite of a positive 16,000?
Negative 16,000.
Negative 16,000. So I subtract 16,000 from both sides. What's going to happen to these 16,000s? They will cancel out. It'll become 0. Over here, I'm going to have negative 16,000. And here, I'm going to bring down my negative 32x. And then, Ms. Gutierrez, do you know what I do from here? Okay, well, what's happening? You want to get x alone by itself. So what's happening between the negative 32 and the x? What operation's happening here? Anybody want to help her out? What's happening? Well, no, just tell me, what's happening here? It's multiplication. So we have to do the inverse operation. The opposite of multiplication is division. So what we're going to do is we're going to divide both sides of this equation by negative 32. That is my coefficient. If I divide this side by negative 32, here's what happens. Two negatives make a positive. And when you divide any number by itself, you get
1.
1. So these are going to cancel out. You're going to have just x. 1x, in case you don't realize. Isn't 1x the same as x?
Yes.
Yes. So this will cancel out down to the x. over here, negative 16,000 divided by negative 32. Anybody know what that is in the math? What is it? It's 500. So that means that this balloon will hit the ground in 500 seconds. Splat! Goes the balloon. 500 seconds, that's 8 minutes, 20 seconds.
That's long.
It is if you're falling and you have no parachute, right?
Yeah,
It gives you 8 minutes and 19 seconds to think about what you've done with your life. And you're like, should have played less video games. Probably should have gone outside more. Anyway, no. Oh, all right, questions on this at all? Questions? Anybody? 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 Thanks, there's my balloon. Pop, it goes again. All right, so 4, 3, 2, 1 on this. Now, very important, last section. Lots of writing here, but the good thing is you already know how to do this. Once again, though, we need to remember what our input is, what our output is. Okay. Now, we will not always be given a clearly defined slope and y-intercept. In some situations, I'm just reading this now, we will only be given information regarding the input and the output. It will then be up to us to identify coordinate pairs from this information, and then we go through the process. Once you know coordinate pairs, do you know how to find the slope of coordinate pairs, yes or no?
Yes.
Yes.
Do you know how to find the y-intercept once you know the slope? Then you know how to write an equation? Yes. If you have the slope and the y-intercept, can't you write the equation?
Yeah.
Yes, and then finally solve. Now, let's look at the first situation here. The rent charge for space in an office building is a linear relationship related to the size of the space rented. We want to write an equation. Lots of wording. Let's just look at this. Monthly rates, 500 square feet for $1,000, or 800 square feet for $1,600. So we have two quantities here. We have square feet of rental space, and we have the total cost. Anyone care to guess what the input is in this situation? I should see a lot more hands up than this. Jennifer, what's the input, square feet or total cost? Think about what goes into this situation and what comes out. Square feet is my input. Depending on the size of the office that I rent, that I get into, my cost is going to change. So the output depends on the input, the cost depends on the square feet. Square feet, input, output is the cost to rent. Once we know that, guess what? It's real simple to write coordinate pairs, because I have coordinate pairs right here. And right here. So square foot, the input. Now the input, is that the x or the y? Let's try this again. Input's the x, output is the y. Okay. So let's write our coordinate pairs from this information. Let's go to the cards here. Some people are like, oh, I saw the cards. Drew. Looking at this information here, what are my coordinate pairs going to be? Give them to me in x, y order. Square feet's the input's the x. So what are your x values here? 500 and 800 square feet. What's your output? What are your y values here?
1,606.
Yeah. So the first coordinate here is going to be 500 on the x, comma, 1,000 on the y. And then what's the other coordinate pair going to be, Chris?
800, 1,600.
Perfect. And that's my other coordinate pair. And then once you guys have the coordinate pairs, we've done the rest of this over and over and over. Do you know how to find the slope from coordinate pairs? Yes or no?
Yeah.
Yes. Do you know how to find the y-intercept once you have the slope?
Yeah.
Yes. Do you know how to write an equation once you have the slope of the y-intercept?
Yes.
Yes, and then we know how to solve it. So now that we've identified the input, the output, we know our coordinate pairs, we go in and we find the slope. Let's go to my homie, Ali. Right there. Ali, we want to find the slope here. Sorry. We want to find the slope here. Oh, who's that? Oh, I'm sorry. The twins, man. I keep messing you guys up.
Twins?
There's like triplets in here. 1, 2, 3. I don't know. Everyone looks. Oh, you guys like similar haircuts. It's dark. I'm going blind. I don't even know. Sorry. Here. This is what happens. You got 9,000 students. Like, I mean, seriously? Shimon, Adrian, and Alaska. They could be twins. I don't know. They're so similar.
Wait, Mr. Wilson, you have 9,000?
I feel like I have 9,000 students.
Oh, I was about to say.
How much do you?
That would be a lot, right? Can you imagine doing that?
The first time you call me by my actual name.
Wait.
All right,
How much do you have?
All right, enough. All right, so Ali, what's my y2?
800.
Okay, remember Ali. Hold on. 1600. Please remember that coordinate pairs are written x, comma y. So that's a y value. That's a y value. That's going to be your y2. So what's your x1 then?
500.
Good. I'm going to throw curveballs at you. What's your x2? 800. And lastly, what's your y1?
1,000.
Okay. Let's plug these into the slope formula. Tell me, what am I going to write?
First you're gonna write 1600 minus 1,000.
1600 minus 1000. Okay.
That equals 600.
Okay. Well, let's just write the whole formula out first. And solve it.
800 minus 500.
800 minus 500. Okay. So this becomes 600. This is 300. What's 600 divided by 300?
2 over 1. Oh.
2 over 1, which is the same as
2.
2. So I know my slope. My slope is 2. Now I need the y-intercept. We've done this before. Rewrite our equation. Y equals mx plus b. I know that my m is 2. And then let's go to... Oh, he's not here, poor kid. Shimon. How do I find the y-intercept here? What do I do now?
It's the same thing for another.
Oh yeah, same thing. So you know the slope, now you just need to pick a set of coordinate pairs. Which one do you want to use? 500 and 1,000?
Yeah.
Okay, so what's going to go here? 500 or 1,000? 1,000, that's my y value. Good. Times 500 plus b. 1,000 is equal to, what's 2 times 500? 1,000 plus b. And then what do we do to solve this?
You do 1,000 minus.
Yeah, subtract 1,000 from both sides. And it looks like this is going to be a proportional relationship because my y-intercept is going to be
0.
0. And that makes sense, right? Real world context, if you're not renting anything, are you going to pay anything?
No.
No, you're not. So there should be no y-intercept there, technically speaking. So you write the equation as y is equal to
2x.
2x. That's my equation. Last but not least, how much would 2,240 square feet of space cost? Now, square feet, was that my input or my output? Input, which means that an x value or a y value? X. So we're going to substitute this in for x. And it's going to be y equals 2. Llama, you already have it done, so tell me, what am I substituting in for the x?
We're going to put 2,240.
2,240, we're substituting in for x. And what's that going to give me? Y is equal to
4,480.
4,480. So if we rent an office that is 2,240 feet, we're going to pay $4,480 per month. The only thing out of all of this that was new was pulling these two coordinate pairs out of the situation. You just have to identify the input and the output, which we've done before. Everything else we've done before. You had a question, Connor?
No.
I thought you did. Any questions on this one at all? Thank you. Shimon, I think I want you to take it. Okay. Does everyone have this written in? All right, I'll let you catch up. Dale! Dale! Math problems come and I want to go home. Dale! Dale! I see the intercept, it makes me cry. Some of you are like, right here, same. All right, last problem. Maldonado, read that for me.
At 59 degrees Fahrenheit, crickets chirp at a rate of 76 times per minute, and at 65 degrees Fahrenheit, they chirp 100 times per minute. Write according to the slope-intercept form that represents the situation.
Okay, so 59 degrees. At that temperature, if we put in that temperature, 76 chirps. At 65 degrees, 100 chirps. So let's go to Miss Vega. Miss Vega, what's my input? What's my output there? We have two different quantities. We have temperature and chirps. What do you think is the input? What's the output? Chirps would be what? The input or the output? So you're saying that, now let's think about this, real world context. You're saying that the crickets chirping changes the temperature? That doesn't make sense, right? So let's reverse that out. But if the temperature changes, maybe it's warming up those crickets and they're going, that's not really how crickets sound, but you get the idea. So, we'll try it again. What's the input, what's the output? Input's the temperature, output is the chirps. So, input's temperature, output's the chirps. That's my x, that's my y. I can write coordinate pairs from this information now. What is my first coordinate pair going to be, Sydney?
59, 76.
Yeah, temperature is the x, chirps are the y. So my first coordinate pair is 59, 76. Muy bien. Rachel, Thomas. Don't worry, Sydney, I forget you. She's looking at me like, where's my ticket? Rachel Thomas, what's the other coordinate pair here?
65 and 100.
65 and 100. 65 degrees, 100 chirpies. 65, 100. Good. Let's go find the slope. Miguel, hold up. I need to find the slope, so walk me through the process. What's my y2, y1, x2, x1? What's all that happy goodness?
The y2 is 100.
That's 100. That's my y2. Good.
The x2 is 65.
Beautiful.
The y1 is 76.
Beautiful.
The x1 is 59.
Very good. All right. Now let's find the slope. Let's go to Corey. Corey, tell me, what am I writing in my formula now? Now that I've got it all sorted out. What am I going to write?
You're gonna write 100 minus 76.
Okay.
And then 65 minus 59.
Okay, and when we do the math here, it's 59 by the way, we're going to get 24 over 6, which divides down to 4. So my slope is 4. Now I need to identify the y-intercept. I don't think this is going to be a proportional situation. Let's go find the y-intercept and find out. Nolasco, it's you. Nolasco, we want to find the y-intercept, so to do that, we first write our equation. Y equals mx plus b. What do you already know?
The slope.
My slope is 4. And then what are you going to use for y and x?
For y and x. For y, I'm going to use the chirp.
Okay, well, we already know that, right? But which coordinate pair are you going to use?
Oh, the 65 and 100.
So she's going to use 65, 100. Okay, so what goes here?
100.
100, the y value. What goes here?
65.
65 plus 8. We bring down the 100. What's 4 times 65? She's got it. She has a calculator, but she's doing it by paper. So whatever works, amen, whatever works. Most calculators, yes. Do anybody want to help her out real quick? What is it?
260.
236. Wait, what? No?
260.
Oh.
4 times 65
Oh.
is 260.
Oh, I was
Use the other one,
doing
you'll
the
still get the
different
same
one.
answer. But 4 times 5 is 20. 4 times 60 is 240. 240 plus 20 is 260. So we subtract 260 from both sides. You should get the same answer regardless. You should end up with B, those cancel, is equal to negative 160 degrees. That makes sense because that means that when the temperature goes down, so do the chirps. We write our equation. What's our equation going to be? Y equals 4x
Plus
minus 160. I don't know who said 160x, but we identified our slope over here. This is my b. My b is negative. If my b is negative, we don't write plus minus. We just write minus 160. So we have our equation. Last but not least, we evaluate it. We want to know at 81 degrees, how many chirps per minute would there be? So we go way back to the beginning of the problem. It's 81 degrees. Is that an x value or a y value? Everybody look up here, please. Fiamma. 81 degrees. That temperature. Is that x or y? X. So when we plug 81 into this equation, are we plugging it in for x or y? For x. Good job. And we're going to have y is equal to 4 times 81 minus 160. Minus 160. And what is 4 times 81? Anybody? 324. So we get y equals 324 minus 160, which means that is 164. So at 81 degrees, those little crickets are going chirping like crazy. Once again, disclaimer, that is not how crickets sound in the real world. I do owe some people some tickets here. We owe Alaska, Fiamma. Who else? Somebody else help me with that, I think. That. Any questions on this? Any questions? See, it starts off easy, but then the math gets involved, and really most of this stuff you've done. Question for you. Have you done step 3 before?
Yes.
You've done step 4 before?
Yes.
You've done step 5 before?
Yes.
Yes. You've even done this before,
Yep.
technically speaking, right? You've substituted in before. The only real thing is you're pulling coordinate pairs out of a situation. Just go through your steps and you will be fine. And if you're not fine, ask me for help. Questions, none? All right.